Hello friends, welcome back to my channel. Hope you all are doing well. Today I'm going to solve LeetCode problem number 1472, design browser history. In this problem we are given a browser. So basically we assume that we have a browser and we only have one tab, and we start from the home page on that tab, and then we can visit any URL from that tab. And also we could go back in the history and go forward in the history. So the history will have the history of all the URLs that we have visited, and while we go back in the history we can move n number of steps, and we can move n number of steps forward in the history as well. So in this problem we need to implement a browser history class. So in this class, what functions do we have? So this is a browser history constructor function where we are going to initialize the object with the home page of our browser. And in the visit function we are going to visit this URL from the current page that we are in. And while we visit any URL from our current page, any history that we had after that current page, like beyond that current page, all of those forward history are going to be deleted. That is basically we are replacing the history from this current page. And then we could also go back steps number in our history. So suppose the number of steps we want to take is equals to k, so we could go back k steps in the history and we would land to the page that we were at that time, at that index. Like after our k steps back to the history. So if in case we are going back in our history and we could only, like, there are only suppose there are only 10 number of 10 number of URLs that we visited back in our history from our current page, and if we are looking for steps equals to 12, then we do not have the 12 history, right? Back in history we only have 10 in history. So we are actually, in that case, we are going to return the index at the one that we visited in, like, the last, that would be basically the first URL that we visited. So basically we are taking at most these many number of steps. Similar in case of we are moving forward, so we move forward steps, and if we only have x steps in the history forward but the number of steps is greater than x, then we only move forward x steps. So let me just clear out these things once again here. So we are given this example. Let's look at this example. Okay, so first of all, we need to initialize our browser history. So we are going to initialize that with leetcode.com. So our home page is starting from leetcode.com. So home page becomes leetcode.com. From home page, what are we visiting? We are visiting google.com, right? So we visit google.com from our home page, so that all these two URLs are saved in our history. And so far our current head is at google.com. So from google.com we are again visiting facebook.com. So now we visit facebook.com from google.com. So our current page is at facebook.com. And then from facebook.com again we are visiting youtube.com. So next we will have our current page at youtube.com. So what is the next step? We are going back one step. So from youtube.com, what do is we go back one step. So going back one step would be that our current page will now point to facebook.com. So next step, we are again going back one step. So that means that we are now at google.com. Now we move forward one step again. So now here we are moving forward, so we'll again go to facebook.com. From facebook.com, what are we doing? We are visiting a new URL, so we are visiting linkedin.com. So what we do now is, instead of youtube.com, now we'll have linkedin.com. that is, all the forward history gets deleted when we visit a URL, right? So that's what's said here. It clears up all the forward history. So we cleared the forward history, and now we have linkedin.com here. So let's suppose we had visited more URLs like reddit.com and URLs like hackerrank.com and so on. So even if our current position is at facebook.com, and from facebook.com we visit linkedin.com, we would delete all of these forward histories. So all of these will go, and we'll have linkedin.com here. So, and our current position, our current page will be linkedin.com. So this is how it works. Now if we are going back, let's suppose we want to go back 5 steps. So can we go back 5 steps? Let's say, so we can go back from LinkedIn to Facebook. That would be 1 step. From Facebook to Google, that is 2 steps. And from Google to LeetCode.com, that is 3 steps. Can we go back anymore? No, we cannot, because we do not have any histories towards the back, right? So the maximum step we could take is the number of the number of histories that we have back there. So what we could do is, if we have the steps, if steps is greater than the number of steps that we could take, the maximum number of steps, then we just go x number of steps. So what we can do here is okay, let's first see how we could solve this problem using JavaScript. So how do we actually store this whole browser history? We need to store it in some data structure. So what would be the best data structure to store it? Just by looking at this, we could see like linked list would be a good option, right? Because we have LeetCode. From LeetCode we are pointing to google.com, and then from Google we are pointing to facebook.com, and so on. So linked list looks like a good data structure, but is that an optimal one? Let's see. So if from this current page I want to go, like suppose I have a very large history, browsing history. So from this current page I want to go to 100 go forward 100 steps. So what do I have to do in case of linked list? Well, I have to traverse each of the node, right? From this I go to this and then this, because I cannot jump direct to the 100th step, because I do not have any reference or any index for that, right? So that would mean that if I want to traverse n number of steps, then I will have to traverse n number of nodes. That would be O of n time complexity, and the space complexity is the total number of URLs that we have visited so far. So like, is O of n optimal solution? Well, we could solve it using more optimal solution, that is by using an array. So if we store this whole thing in an array, so we will have an array, and each of these browsing history will be indexed, right? So while we have indexed browsing history, so what we could do is, if my current head is at LeetCode.com, which is at index 0, and I want to go to an index which is, I want to go forward n number of steps. So how can I reach that? Well, I can just do is like I can do 0 plus n, and that would be n number of steps, and I'll be there. Like in this example, if I want to go like 3 number of steps, I could just do 0 plus 3. So where will I land? I will land in LeetCode.com because this is at index 3, right? So I can just traverse back and forward in O of n, O of 1 time complexity, that's constant time complexity. So that is why we are going to use array. So now we know that the data structure that we are going to use, and we also know that while we visit, we are always deleting the forward history, and while we go back, we can only go maximum number of steps that is allowed, so at most steps number. So let's see now how we could let's start to write our code. So okay, so we are storing it in our array, our browsing history. So now our browsing history starts from the home page, and we are also storing the head, that is the index that we are, our current page, index of the current page. And while we visit, we are always visiting like starting from this index, from our current page, since current page is here. And if we visit a new URL, everything after this will be deleted, and we'll add our new URL here. So what we do here is we just update our head index, and then at that index, so we update, we go one step, and then at this index we add our new URL. So now we have our updated index, our new URL at that index at would be equals to the URL that we are visiting. And then we also need to take care of the length, right? Because okay, because if in this case we just like what we did is we go next step, and then we just updated this url.com, right? But then if we don't we update the length, that is we will not be able to get rid of these things. We want to get rid of these things, so we are also going to update the length. So what we'll do is, okay, I'll also again have to rewrite this. So array equals to URL. So we are going to update the length of the array, and that would be equals to this head plus 1, because now head is the last URL that we visit. So the index, last index plus 1. Now while we are going back, what we do is our head, we will just update our head equals minus equals to, because we are going back, so we are going to decrease our head steps, number of steps. Now if head is negative, that is if we went we could not go beyond this, right? So if head is negative, then we will return the first index value at the first index. So if head is less than 0, then we are going to return this dot head would be equals to 0, else we are just returning the value of the head. So now this array is this head, and we return this value. Similar is the case with while we move forward. So here we are actually adding the value, and then if the length of, if our head is greater than or equals to the length of the array, then our head will be equals to the last index. Okay, and then we return the value of the array at that index. Now let's try to run our code and look for any errors that we might get. Okay, this So I got some. Okay, so this. Awesome, let's try to submit it. Great. Hope you liked my solution. Let me know in the comments down below what do you think about my solution and if you have any feedbacks for me.